Hey guys, welcome to KK Java Tutorials. In this video tutorial, we'll talk about selection sort. First of all, we'll understand selection sort algorithm, and then after we'll move for its implementation in Java. So let's start. So here, let's try to understand through an example, right? So let's say I have one array of size 4, and this is the input array 7, 5, 4, 2, right? And I would like to sort it using selection sort. So in selection sort, basically we always start with the 0th index. We assume that 0th index is the smallest element, and then 0th element, first element of the array, we have to compare with all the elements of the right side array, right? So let's say 7 I compare with the 5. That means 5 is the smallest, smaller than 7. Then we'll put we will set this index as the minimum index, and then I'll compare 5 with the next array element, that is 4. Now if I compare with these two, 5 is of course 5 and 4, of course 4 is the smaller, so we will put a smaller index, we will set the smaller index 4. Now again we will compare 4 and 2, so 2 is the smaller one. Then minimum index, minimum element index will set as the 2. Now we will compare which is the minimum elements right after the 7, means 0th index after 0th right elements after 0th index. Then we'll swap these two, right? So we'll save 7 will come over here and 2 will come over here. So array will look like this. So first iteration, smallest elements will be putting on the first index of the array, and rest of the array is still unsorted. Now same. So this happens in the first iteration or first pass. Now in next iteration, we'll move cursor index plus 1, so that will on the first index, and then first index will compare, first index array will compare with all the elements of the right side. So 5 compare with the 4, so 4 is the smaller. So now mean elements index would be whatever index of the 4. Then 4 compare with the 7, then still 4 is the smaller. Then these 5 and 4 will be swapped. So 4 comes over here and 5 comes over here. Arrays will look like. So 2 and 4 is now sorted, and 5, 7 still is unsorted. Of course this is sorted, but algorithm doesn't know about it. So this process basically repeated. And let's say if you have an input size of 4, then we required total 4 iteration or 4 passes to sort complete array. So here idea is that basically in selection sort, we start with the 0th index, and minimum element we put on the 0th index. Again we'll move the cursor and we'll take the first index and check right side the all the array, whichever is the smallest we'll put on the first index. So this is the way basically selection sort works. Now let's see how we can implement selection sort in Java. So here I haven't created a code for selection sort, but some of the code already I have written, like taking input array size from the keyboard using a scanner and storing in the input array size variable. And I have created an array with this size, and now I'm asking user to enter the elements in this input array. User is entering all the elements and populating into this input array. Now original array I'm printing with the help of arrays.toString. And now we need to write a algorithm or method for selection sort, right? So this is the method which we are going to write. Now once array is sorted, right, then this method will return sorted array, and then this sorted array we are displaying using arrays.toString, right? So here basically we have to write a code for selection sort. So in selection sort, basically logic for writing the selection sort, basically there are two for loops. The outer loop starts from the leftmost element and goes till the one less than the number of elements in the array, and inner loop starts at the index 1 more than the current index of the outer loop and goes till the end of the array, right? Now I'm going to write one loop, right? So array has to start from the 0th index, and that will go array size minus length 1, right? This much iteration we needed, right? Now let's say as per the algorithm, I'm going to assume right here one variable like smallest index, means a smallest index I am going to put set as I, right? And now we required one more loop, right? Inner loop. So, and that inner loop has to start from the I plus 1 and I plus 1, sorry, it's not I plus I but I plus 1, and that has to go till array length minus 1, less than array minus 1. Yeah, now here inside this, here you have to check, right? What we are going to check over here, input, let's say input array, and here I says j less than input array smallest index. If that is the case, means what happened, that means array has a smaller element whatever we have stored on the this index, right? In that case, we have to reset this smallest index, right, equals to j, what we have discussed in the slide, right? Now in that way we are completing one iteration. So if one iteration is completed, means we have decided the what is the smallest index, smallest element index, and that we are setting into the smallest index equal to j, right? Now we have to come out from the inner loop, and there we have to do kind of swapping, right? Now I write int smallest element. Smallest element means first iteration, right? Smallest element equals to input array of this smallest index, right? Now, so just I'm using third variable, third kind of temporary variable to swap these two elements. Now this will be input array of I, okay, and then input array of I equal to, this is just a swapping, right? It's so simple, equals to this guy, just we have swapped out, right? And now we have to return, sorry, here equals here yeah, of course you have to assign this variable so that swapping will happen. Yeah, so simple. Now this array, sorted array, has to return, right? Now almost we have done. Now let's run and see the output. So if I run it, then I'm going to supply the value of array size is 5, then 5 elements I have to enter. Let's say 120, 400, 30, 40, 56. Now here you can see the input array has been displayed in the same order in which we have entered the element, and here array is sorted, right? Here you can see array is sorted. It's not sorted, basically 120 is coming at the last, so there is some problem in the algorithm. Let's see what's the problem. Now here I equals to 0, this is correct. Now I'm setting initially smallest index I, then start, okay guys, I plus 1, this should be I plus 1. So that's the problem. Now let's run this program again. There is some typo, so 5, let's say 120, 40, 200, 30, 90, right? Now here you can see this is the input array, our input array, and this is the array which is in sorted, right? Now array is in sorted. So if you look into the algorithm is pretty cool, pretty simple. So we take the input array, we iterate array, complete array starting from the 0 to length minus 1, and we set initial smallest index at 0. Now we have another loop which we have to start from index plus 1, and that's why I plus 1 I have given, and we have to go till less than length minus array length, till array length. And here we are checking if input array of jth less than equal to smallest, which already we have set it this index. If that is the case, means array has a smallest element than whatever index earlier we have set it. So we will reset this smallest index as equal to j, and in that way, when you set the index, then one iteration is already completed, right? So we'll come out from the inner loop, and there we'll do the swapping, right? To do the swapping, I have taken the one temporary variable is called smallest element equals to, I have assigned the element which is at the smallest index, right, which is jth index, right? And then a smallest index, I'm putting elements of the whatever in the array of ith position, and then that ith position I'm storing the smallest element. So this, there we are doing kind of swapping. So guys, as far as time complexity concern, we have a loop inside the loop, right? So even this loop is going to iterate basically O of n, right? And this loop is going to iterate almost O into n into n minus 1 by 2 times, right? So there is a loop inside loop. So overall time complexity will be proportional to n square. So time complexity is a big O of n square. And this algorithm basically supports the in place. So in place, why I'm telling you the in place, supporting the in place in nature, because we required only one variable, right, to store our temporary result, right? So this is taking basically a space complexity would be O of 1, right? So and of course that's it, right? So if you look into the, if you compare with the bubble sort, right, selection sort is a little faster because number of comparison in the selection sort is comparatively lesser than bubble sort, and that's the reason selection sort is faster than bubble sort. So that's all I wanted to discuss in this video tutorial, guys. I hope you enjoyed this video. If you really like this video, then hit on the like button. Don't subscribe KK Java Tutorial till yet, then please go ahead and subscribe. Guys, big thank you, and see you there in the next video.